Alright, I'm gonna try to get some more of our ostrich class working. Because right now, our ostrich, our pterodactyl. So right now our pterodactyl is just, you know, just flying. All it does is move its X position and change its animation frames. So I think I want to, we need to add a way for it. We need to add collision, both on platforms and vultures and an ostrich. You know, different collision logic for all of those. And then we also need a timer to spawn the pterodactyl if you don't get any vulture kills after X amount of time. So maybe the first thing we do is test in time how long it takes for a pterodactyl to come out, and then we test, if we kill a vulture right before that time frame, if it pushes it back another 20 seconds or whatever the time frame happens to be. So I guess let's just test it down here. So I'm gonna, here, look, they're all spawning. I'm gonna set, I already fucked up. I've gotta get my timer ready before. Here we go. So look, wave 1, I'm gonna start the timer as soon as they spawn. Spawn, okay. So now I'm not gonna kill anybody and see how long it takes until a pterodactyl comes out. Oh, and you know what? I think us dying changes the time too. Shoot. Yeah, I think us dying resets the timer on it. Because it's been 30 seconds and no sign of pterodactyl just yet, and we keep dying, so I might have to reset the timer and run around and survive in order for the pterodactyl to come out. Because yeah, it's been almost 50 seconds. And no pterodactyl yet. Okay, I'm gonna restart it. I'm gonna restart the timer. And I'm gonna survive. And then we'll just see what timer it is once it comes out. Started the timer. Now we just gotta survive and not kill anything. Oh my god, this is hard. Come on, pterodactyl, come on. I'm doing so good not doing anything. Come out, pterodactyl. Fuck, I killed him at 40 seconds. Okay. Fuck. We gotta do it again. We know it's past 40 seconds, so I guess that's a bigger time frame than I thought. I thought it would be 20 seconds. Does it come out on wave 1? I'm pretty sure it does come out on wave 1. "43 seconds, no pterodactyl. 50 seconds, no pterodactyl. You're coming up on a minute. 3, 2, 1 minute. No pterodactyl. There might not be a pterodactyl on wave 1. Yeah, might not be a pterodactyl on wave 1 because it's been over a minute and no pterodactyl. I think it's pretty safe to say no pterodactyl on wave 1 after a minute 20. Oh, pterodactyl came out 1:30. Came out at 1:30 on wave 1. Fuck, what an asshole. Okay. I'm gonna see, so 1:30 on wave 1, that's when the pterodactyl came out. I'm gonna reset the timer. Reset it once wave 2 comes. And starting, I'm gonna just do the same thing where I just survive and not kill anybody. Whoa, whoa, did you see that? Oh, no, 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 fuck. I didn't want to kill him. Okay, it's easier to not kill 1 than it is to not kill 4, so it's actually a good idea to kill all but 1, and then see how long it takes pterodactyl to come out. Bro, he came out right away. I think they come out faster the less, he came out after 7 seconds. So like, let's try it again, like reset. There's 1 left. I think they come out, it comes out faster the less there are. He came out 20 seconds. And then he disappears after you get killed by him. And then same if you die. If you die, he'll disappear. So 20 seconds if there's 1 left. About, you know, I couldn't get it consistent, but then a minute 30 with 3 left. So it's almost like it's 20 or 30 seconds per vulture. How did we kill him? He hit our asshole and we killed him. That was pretty dope. Okay. Okay. So we have to set the animation timer or the spawn timer on our pterodactyl based on how many vultures are left, I'm pretty sure. Because when we had 3 vultures left, it took a minute and a half, and 1 vulture left took 20 seconds. So maybe we just say if there's been no collision, there's been no player to enemy collision in 20 seconds for every vulture that's on screen. So that sounds about right to me. Because 130 sounds a bit generous for 3 on screen. So if you kill a vulture every 20 seconds, you'll never see a pterodactyl. But also, if it takes you a minute 20 to kill the first one, and then just under a minute to kill the second, and then 20 seconds to kill the third, you'll also never see a pterodactyl. So maybe something like that. Gosh, you guys, I'm like awfully tired. Instead of doing this where we're looping, well, goddamn. Yeah, we needed to do this based on DX instead. Oh my god, I'm so tired. We need to, yeah, we need a facing direction, and then we gave ourselves a DX, so I guess. I don't know. It seemed like the pterodactyl was kind of flying in zigzags. don't exactly know though. I don't even know what to do. I don't know what to start. Work gave me a bunch of new videos that I got due. So I think I'm just kind of stressed out about that. And then just not really feeling too excited to get programming done. Let's say our x gets our current x plus our self.dx, and our dx defaults to positive, meaning moving to the right, but we can also swap that. Okay. So we're updating our x position based on our dx now, and dx is just change in x, delta x, which for now is going to be positive, but we need to randomize whether or not the vulture's going to, or whether or not the pterodactyl starts off flying off screen from the right to the left, or off screen left flying to the right. You know, positive dx going to the right, negative dx going to the left. We need some collision detection for our pterodactyl. It feels so redundant to have to write AABB collision for every single class, because most of our classes have AABB collision. But yeah, maybe that's one thing we need to, I don't know. Vultures have a little bit different collision than our player does because of choices we made, so maybe it's fine. So we need a couple of new functions, right? We need a left collides. So a pterodactyl can also top collide with a platform. It should bounce it downwards or whatever. And then it should also bottom collide with the platform, meaning it should bounce back up. And we can use our generic left collide and right collide to determine, we can, you know, cycle through all the platforms, do all the pterodactyl and platform collisions, which would bounce the pterodactyl the other directions and whatnot. But then we would also need to, we can apply that same function for our player, left collides with the player, and if there is a way you can kill the pterodactyl if you joust him when his mouth is open or something, you can kill him. Like if you joust him right in the mouth when his mouth is open, you can actually kill him. So we'll have to write that stuff. We could do that with using these. We just, instead of the platforms, we pass in our player object. And then what else? I think that's okay. I think that's a good start. Yeah, gosh, I'm just like so, I'm fried and sad and stressed out, but let's just try to do it. I like to draw the collision detection just because it helps me out with the coding. So for left collision, we're checking if the left side of our ostrich is smaller than the right side of our collidable. and the left side of our ostrich greater than the left side of our right, the leftmost side of our right collidable bounding box of our platform or character. So we would say our pterodactyl's X would need to be bigger than the left side of that bounding box, and the left side of that bounding box is going to be not the right side of it, but maybe, you know, its X plus 1/2 of its width. Okay, so that's the X's. And instead of, if you look at our code here, see how it goes way off screen here? I'm going to do a nested if to make it so it doesn't go so far off screen, which I should probably update that other code. So I'm going to do the Y's here on this second line. So in order for our left collides to be true, our X's have to be aligned, but then our Y's have to also be aligned. So our pterodactyl's Y would need to be smaller. So the top side of our pterodactyl would need to be smaller than the bottom side of our collidable. And the bottom of our pterodactyl, and you know what? Yeah, okay. The X's is the only one we have to check this divided by 2. Because we're checking how far inwards, but our Y's need to be spot on for the same collision. We're not giving any buffer on those. Well, it's like, the reason I did it like that with the divide by 2 is so that it's a more accurate collision detection, because we can trigger, if it's just true axis line bounding boxes, it would be just collision detected on any collision, but we're only checking for the certain left collision so that we can get more accurate logic applied. So we're checking to see if our ostriches so we're checking to see if the top of our pterodactyl is smaller than the bottom of our collidable, and the bottom of our ostrich would need to be, top would need to be smaller than the bottom, and then our bottom would need to be greater than the top. Yeah, greater than the top, which is just collidable.y. And if all those are true, we return true for our left collide function, and then not return false. So there's our left collides. Let's do our right collides. We're going to check to see it really helps me to sketch it out. So this is our pterodactyl. Okay, so right collide pterodactyl, we're going to be seeing if the leftmost side of our bounding box on our pterodactyl, which is going to be our self.x plus, this is where that half comes in, plus self.width divided by 2. So if the middle of our pterodactyl is greater than, the leftmost side is smaller than the rightmost side, so smaller than the rightmost side of our collidable, which is our collidable point x, dot x rather, plus, then we need that half again. This is why it helps me to sketch it out. Our collidable's width divided by 2, So we're seeing if the left side of, or the middle of our ostrich is to the left side of the rightmost side of the bounding box of our collidable platform. Yeah. Yeah, so our x, the left side of us, needs to be less than the rightmost side of the bounding box of the collidable, of the platform, or player, so just collidable. Needs to be smaller than that. And the rightmost side, which is our self.x plus self.width. So the right side of our ostrich needs to be greater than the leftmost side of our collidable. Then we can check the y's, and we would need to see if our y is the top of our pterodactyl. So our y would need to be smaller than the bottom of our collidable. So collidable y plus height, and the so top of our ostrich needs to be smaller than the bottom, and the top or the bottom of our ostrich would need to be greater than the topmost part of our collidable. And if all that's true, then we do have a collision. So we return true, and otherwise return false. There's our right collides. Now top collides. This is mainly for platforms. I don't think it's really so much for the player, but we probably need to cover our bases, so I don't know. So, all my pins are freaking dead. Pterodactyl top half on a bottom half of a platform. So the divide by half is going to be on the y's instead of the x, because we're doing the top and bottom collision now this time. So happy Halloween, guys. Just realized we kind of got a Halloween color theme going on. Orange and black. Just with that one part, whatever. Okay. We're gonna say do our x's. So our left side of our ostrich would need to be smaller than the rightmost side of our collidable. And our right side of our ostrich would need to be greater than the leftmost side of our collidable. And the collidable is just the parameter that gets passed in, and any parameter that gets passed in will need to have an x, a y, and a width and a height in order for the collision to be detected or determined. Otherwise, this will be a nil, and Lua will fail. Then we need, if then. So, top of our ostrich would need to be smaller than the bottom of our collidable. And the bottom of our bounding box of our pterodactyl, which would be self.y plus, that's where the half comes in, self.height divided by 2, so half of our ostrich. And then the order of operations matters here too, right? Because we have to detect, or we have to decide whether or not we want to check for side collision first or top collision first. Because if it kind of hits in the corner, both the left, or if it hits in the corner, both the side collision and the top collision will be detected. So we have to determine what makes the most sense. Probably a side collision first. I don't know why, but probably. Excuse me. So our top of our pterodactyl needs to be smaller than the bottom of our collidable, and the middle of our ostrich would need to be greater than top needs to be smaller than the bottom, and our bottom needs to be greater than the middle. Yeah. This needs to be greater than the middle of our collidable platform, or person, or whatever, object. And if all those are true, we know a top collision has happened. Otherwise, return false. Now we need bottom collision so we can bounce off the floor. Gotta sketch it out real quick because it just helps me. Pterodactyl. I need to get new pens. Okay. So we're gonna see, let's do our X's first. The left side of us is smaller than the right side of our collidable platform, and the right side of us is greater than the left side of our collidable. Then we say our ostrich, top of our ostrich, and this isn't actually the top of our ostrich, we're doing bottom collision, so the top of our ostrich bounding box, which would be this plus half of our height. So top of our bounding box would need to be smaller than the top half of our collidable. And the bottom of our vulture, our bottom of the pterodactyl would need to be greater than the top of our collidable. That might be true. I mean, I don't know. I don't know if I got it right. What we can do is now implement all of these. I'm going to give a dy of 5, and then I'm going to update our y by its current y, shifted by our upwards velocity or downwards velocity. Since it's positive, it would be downwards. So now our ostrich should be going, it should be going to the right and downwards, but then that'll allow us to now, in our play state, we need to cycle through. Fuck. We're cycling through every vulture here, moving them to the graveyard. So we need a... I think these are all local. These are all local to the scope of, like, this eye is only accessible in this block, I'm pretty sure. So I think I can just add a whole nother block of pterodactyl cycling. And updating our monster. Our monster is our pterodactyl instantiation. So man, guys, sorry guys, I'm just like out of it. We're cycling through all collidable platforms here, checking egg collision. Do we tack in vulture or pterodactyl collision with these platforms here? Or do we keep it separate? Yeah, we also need to cycle through all the vultures. Check. I think I'm gonna keep them separate for clarity's sake. Yeah. We can always move them, factor them in together if I want to do it differently. But at least for testing purposes, I kind of feel like it makes sense to have them all in one spot, so I'm not getting it all mixed up with all of this code and everything, I don't know. So I guess we'll say for key value in pairs collidable platforms, do we'll run. So we say, if our self.monster, which is a pterodactyl instantiation, so we can run our functions we just wrote here. So like if we left collides with any given and by putting v in there, key would be the index, but v is the actual object, which is a table of all of those values. So this loop will cycle through every object within collidable platforms, which are all platform instantiations, and accessible by the value here. So we'll say if the left collides with the value, I'm going to say for key platform, collidable platforms, and then I can say platform here, make a little more sense. So if we'll check for left and right collision first. And if we left collide with a platform, we need to set our monster's X to be equal to the right side of said platform. And then we need to swap our dx. So bounce us the opposite direction on the x-axis after we move us to be, and it's not self here, it's self.monster.dx. Okay. So yeah, we're moving it so we're not colliding any longer. And then we're swapping our dx. And then if we right collide, similar. If we right collide, we need to move our x to be equal to the collidable, to the platform's x, shifted by the width of our pterodactyl instantiation. So if the right collides happens, yeah, we move the rightmost side of our pterodactyl to be flush against the left side of the platform it just collided with. And then we're going to do the same thing where we say our monster.dx gets multiplied by a -1. So it should swap us on the x-axis. And then we need to check top and bottom. And the thing is, this gets a little wonky with the bottom because the bottom isn't a collidable platform, it's just the ground, because we need to, we still got to do that shrinking stuff. So, and I was getting those problems with looping because of the collision detection on the ground, on the check grounded function in our ostrich class. It was making us jump when we were going off screen. So I had to fix that. So that's why that's why the ground isn't in the collidable platforms category. It's just a kind of a unique situation. But we need top collides and bottom collides. So we check side collisions first, then top and bottom. And if our pterodactyl does top collide with any given platform, we need to move the top of it to be the bottom. So it's platform Y plus a platform height. And then we need to also, and it's not self, it's self.monster.y. And we also need to swap its dy, so bounce it, because if it's negative, we can say we need a math.absolute value of our current. Because if with top collision is detected, we know we need a positive dx. So we'll just say self.monster dy absolute value. Then if we bottom collide with a platform, we're going to move not our self, but our self.monster.y to be equal to the collidable, not the collidable, but the platform argument y shifted by the self.monster.height. And then if we bottom collide, we know we need it to be a negative to bounce us upwards. So we can just say self.monster.dy times a -1 to bounce us upwards. But we also need to check if our self.monster.y plus self.monster.height, the bottom of our pterodactyl, is greater than the ground, which is our ground. What is our ground? Ground platform. Ground platform is the instantiation of our ground platform. So we can say ground platform X or whatever. If the bottom of R is greater than ground platforms Y, so if the bottom of our pterodactyl goes past the top of our ground platform, then we also need to bounce up. And the reason we have to explicitly add this is because the ground platform isn't in collidable platforms, for the reasons I said before. So if we're grounded, then we're gonna set our monster's Y to be equal to the ground platform's Y minus a self.monster's height. And then we need to get our dy to bounce upwards. So we'll take our monster's dy and multiply it by a -1, bouncing us up. But then we also need, if our self.monster's y is smaller than 0, meaning it's going off the top of the screen, then we need to trigger that top collision, and we have to do that explicitly because the top of the screen isn't a collidable platform. So we have to say explicitly here that our monster's y will get set to be our monster's y will get set to 0, very top of the screen, and we will change our monster's dy to be a positive. So we can say mass.absolute value of our current monster dy. So if we did our functions correctly and we did our we're setting, so like we have we update the monster after we do this in the play state, which is kind of weird, but it kind of makes sense because it's like, we detect a collision, we swap all the right values, but then, if our dx is shifted, what does that actually mean for our monster's x? And that's when this line of code comes in, and it goes, hey, if our dx is this, and then it goes in here and says, okay, well, we need to say that our new x is modified by our dx and modified by our dy. So that's why we have it, we're updating some values here, but then we also say monster update, and that'll actually move the correct values into there. Because we're modifying like the dy and dx and stuff, but the x itself doesn't get modified by the dx and dy until this line. So both of those are important. So I guess now is kind of the moment of truth to see if we just jumbled up everything. So a couple things we've messed up. First and foremost, we don't have it where if our pterodactyl goes off the left side of the screen, it loops to the right, so that's a problem. But our bottom collision's jacked. bottom collision is real jacked. That was better than I was expecting or hoping even. I was expecting a bug because we typed in how many lines, we typed in this many lines plus this many lines without running the code once. And it didn't crash. So that's pretty good. That's a pretty significant amount of logic. Our bottom collides is just straight jacked though. So I'm gonna walk through this and see if I'm making a mistake here. So we're seeing if the top of our pterodactyl is smaller than... Gosh, I need to draw this, man. Oh, okay. Our bottom collides was what was jacked. So we're seeing if our x... See, yeah, this is already messed up. It's not... Oh, no, x. Got it. Okay, so yeah, if the left side of our pterodactyl is smaller than the rightmost of the collidable, and the rightmost of our pterodactyl is greater than the leftmost side of our collidable, so the x's seem right. And then if self... Oh, god dang it. It's hot in this room. I feel like I'm gonna pass out or something. We're seeing if the middle of our pterodactyl is smaller than... Yeah, this is already fucked. So that needs to be a y. And the bottom of our pterodactyl would need to be bigger than the top of that collidable. So yeah, if that's... I'm just curious if that fixes our weird jank bottom collision. Nope. So it goes off the side of the right side of the screen, no problem. It's almost there, like it's actually not bad at all. Something's still jacked. But it does look better. We need to fix, we need to say that if our x, right now we have if our x is greater than the virtual width, if it's all the way off the right side of the screen, move it to the left, but we need if our self.x is smaller than 0. No, if the right side of our vulture, is smaller than 0, then we need to give our x position to be the virtual width just off screen to the right. So now it should be able to move from the left side to the right side of the screen. See what would happen there. Top collision is jacked. Top collision, and then for whatever reason that one was messed up. Bottom collision, it's the order of operations type of deal. Yeah. That was jacked. We need to swap which direction it's facing based on dx. So here we can say if our dx is positive, then our self facing right is true. And then if dx is smaller than 0, we can say else our facing right is false. And then we can use that to change what renders. Right now, we can say if self dot facing right, then render this the right way. Otherwise, it's facing left. Therefore, we need to swap. We need to swap our direction so our vulture's facing the right way. We need the offset. So I wonder if we have an example of that in our player class here. Yeah, offset by a self width. Nice. I can't tell where it's bugging out. That top collision was jacked. I kind of like it a little janky like that, but not so much. See, that shouldn't have been a right collision, that should have been a bottom collision. So there's sometimes we would want to prioritize. I don't know. See, like that was a right collision when it should have been a bottom collision. But we did check for right collision first. So it's like if we changed the order of operations, it would jack up the other way. I think if we, in our play state here, if instead of all these ifs, we say, we do else ifs here, so that only one can be true. Only one collision can be true. So they're not kind of competing. Maybe that'll fix it or help. Not quite. See, like that one was, it detected a right collision when it should have been a top collision. I don't get why that corner is so jacked. I think we need to just make we need to adjust our collision functions to be a little less lenient. Instead of half of the vulture, maybe we do a fourth, or a pterodactyl. So instead of divide by 2, maybe we divide by 4 here. Maybe that'll help. Because we just want more accurate collision detection. So let's see if that helps us. Nope. Oh, see, it fixed that in that corner there. It actually worked better. I'm curious if we do it divide by 5, it might actually kind of fix it. That's awesome. Hey, that's looking not bad. The very first collision, it's still messed up, so I wonder if we make this window just a bit smaller. And what I'm effectively doing, instead of like the true AABB collision, it's like I'm doing like borders, and it detects, I don't know how to explain it, but like a thinner sliver of detection, so it's more accurate. It's the best way I can kind of describe it. See, why does it fuck up right there every single time, that very first one? It shouldn't swap it shouldn't be detecting a right collision first there, which it does. Right. Collision is too sensitive. And it's because the platform's so long, the divide by 5 is still too sensitive. So I think the right and left collisions just need to be more sensitive because the platforms can be longer. Really? It's still messing up. The heck? You know what? What if we do, instead of this ratio, instead of saying our x plus a certain amount, how about we say the rightmost side and in by 3 pixels? And then same with here, where we say not, well, actually, I think I can leave these at 5 for the, no, yeah, not this one. So this one would need to be the same, where we say the right side, but in by 3 pixels. And maybe that'll smooth out the bottom collision here at the beginning. Okay, almost. It should be a bottom collision, not a left collision, so it's still messing up. It's messing up there. See that left collision? It should have been a left collision, but instead it was a right collision, which doesn't make any sense to me. Okay. So instead of, yeah, we're going to rehaul. We're just going to do this by 3 pixels on each side. So instead of the right collide being the middle of our ostrich like we had it divided by 2, we're going to have, you know, the right side minus 3. And then here, y plus height. So instead of that, we're going to be minus 5, the bottom, like y plus the height minus 5. Instead, we're going to do a minus 3 actually. Same with this one. And then same with here. Instead of the middle of our ostrich or whatever, we're saying top of our ostrich minus 3. See, actually, no, yeah, I'm doing this wrong. Greater than this minus 3. Because we need the true bottom collides, we would need to know if the bottom of our ostrich is smaller than ostrich would need to be smaller than the bottom of that, and then the top of our bottom of our ostrich needs to be smaller than the bottom of our collidable. Top of our ostrich needs to be greater than top of our ostrich. Actually, yeah, we need to do plus 8 minus 3 here. I don't know. I don't know if that's right. Still jacking up. Left collision is jacked. No, bottom collision is checked. On the platforms, but not on the ground level. Fuck. Yeah, bottom collision is still checked. You know what? Since we're checking left and right collision first, I think our bottom collision can be more of a true AABB. So if we're gonna be saying that the bottom of our ostrich needs to be smaller than bottom of our pterodactyl, bottom of our pterodactyl needs to be smaller than the bottom of our collidable, and the top of our ostrich needs to be no. Because yeah, we want the middle of our ostrich would need to be greater than. Nope, that's wrong too. How do we do this? Bottom collision would mean that the bottom of our ostrich is smaller than that plus 4, just a couple pixels in, I guess 3 to be nice about it. And then bottom would need to be, oh gosh, what are you doing, man? Top, okay. Let's just do the top of our ostrich first, so like, but it's the, let me just switch these around. Okay, so the topmost of our bounding box of our pterodactyl would need to be... See, this is where it's messing up, because this only needs to be... We're only wanting to check 3 pixels, or... Yeah, we'd want to see if the bottom of our ostrich... minus 3 pixels in is smaller than God, this is why is this so confusing for me? It's almost like we just need to say if the bottom of our right now we're saying if the bottom of our ostrich minus 3 pixels in, so like 3 pixels from the bottom of our ostrich is smaller than the bottom of our collidable, which is 3 pixels. Bottom of our collidable. And then the top of our ostrich. And it's not the top of our ostrich, it's the top of the ostrich bounding box, which would be self-dot height minus 6 maybe. This is getting so crazy. Top of that would need to be bigger than the topmost part. That's so wrong. That's so wrong. See, it's not detecting the bottom collision, right? Do we check bottom collision last? Yeah, we checked bottom collision last, so... I wonder if we just have true AABB here and see if that fixes our problem. Leftmost side is to the left of the right side. Right side is greater than the left side. Then top of our ostrich needs to be smaller than the bottom of the collidable. And the bottom of our, top of our, and then the bottom of our ostrich would need to be bigger than top of. Still messing up. It's still detecting a left collision. The bottom collision just isn't detecting right. I'm curious if we take this whole chunk, we copy this, we comment it out. And we say, what if we check bottom collision first? We say, if bottom collision. See, but this is true. Actually, yeah, this is gonna fuck us. This is only gonna detect bottom collision upon any collision. Yeah, this is not gonna work at all. Yeah, it's only gonna detect bottom collision, which is completely wrong. It's screwing us because we're detecting a right collision. Yeah, why would it be doing that? It's just detecting a right collision when it should be detecting a bottom collision. So maybe if we just, modify our right collision to be even more lenient. What does that even mean? Like our X's need to be even further in for a side collision. Therefore, it gives a chance for the bottom collision to be detected. Fuck, it's still doing it. You know what? I'm gonna have to do what we did with our egg, where we give us a pterodactyl at our mouse, and then we can print out the collisions, and then I just got to get to the bottom of this because it's not right. So we've got the basics of it, we got a great start on it. It looks miles better than the just moving left and right. It'll probably be a bit faster than this, which we can say, boost it by 50%. Yeah. It's a pretty menacing vulture, yeah. And our top collision is just totally jacked. I feel like we had it better a couple iterations ago. We'll figure it out. We'll have to rehaul our functions we wrote today. Once we get, we'll get it on the mouse, and then we can print out the debugging so we can really test this much better. Yeah. This is, God, I don't know. I know we need to fix these. They're so jacked. this should have fixed top collision, but it did not. So we're gonna have to just figure it out next episode. But we did a decent amount. We wrote 4 functions for our pterodactyl, even though they're busted. Then we did some implementation details for the DX and the render for our pterodactyl, and then we did the implementation of our logic. So it's not a bad day. I'm gonna add everything with a commit message saying added initial pterodactyl collision logic. It's broken, but we added it. Push it to our origin main and call it a day. Thanks for watching, guys. I'll catch you tomorrow and we'll get some of this stuff fixed up.